Today we will be talking about the Fibonacci sequence. Now I have written down the first 10 numbers in the Fibonacci sequence. 0, 1, 1, 2, 2, 3, 5, 8, 13, 21, and 34. Now the way you get the Fibonacci sequence is you add the first one with the second one and you get the third one. So for instance, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 3 is 5, 3 plus 5 is 8, and so on. Now I've put them in a graph, and the number of the sequence I have as n, and the value of the number I have as x. So as you see, n, the first number is 0, so x equals 0. And then on n, the second number is 1, so x equals 1. Now the reason I put it in this table is because it's easier to come up with the formula from this table. So the formula we get is x of n equals x of n minus 1 plus x of n minus 2. Now before you freak out, it's really not that hard. We'll just break it down. So x of n, the n is 10. So let's go over here and find 10. The x value is 34. So we'll go ahead and put 34 there. And then the x of 9, the value is 21. So we'll go ahead and put 21 here. And the x of 8 is 13. We'll go ahead and put 13 here. So the x of 10 should equal these two numbers added together. And 21 plus 13 does give us 34. Now what does all this have to do with the golden ratio? Well, Fibonacci came up with this formula, and he also realized that these numbers, when divided together, come out to a specific number called the golden ratio. The golden ratio you can find everywhere, in nature, and plenty of drawings from the European, like such as Leonardo da Vinci's Mona Lisa, and a lot of the Greek architecture come from the golden ratio as well. Now how we get the golden ratio is pretty simple. It's x of n divided by x of n plus 1. So again, I put the table out here, and I found it easier to draw it up and down this time because we're using just the x values and dividing them. So we'll take x of n 21. So 21 divided by x of n plus 1, which was 10, the value is 34. So we get 21 divided by 34. And then it comes out to 0.61764705888. But we'll go ahead and just round that to 0.618. We're trying to get this whole golden ratio. So we'll round it till it equals. Now let's go to the next one. 34 divided by 55. We get 0.61818181882. And we'll go ahead and round this one so we can get the Fibonacci number. Now Fibonacci also found out that the bigger the numbers are, the closer the number is to the golden ratio. For instance, 144 divided by 3 gives us 0.61803, which is a lot closer than if we just take 21 divided by 34 and get 0.618.